Okay, good morning, everyone. How did the homework go? Do you have any questions about the homework? Please put them on the chat. You should have some. Anybody? Okay, so before I start the homework, I would like to make 2 comments about the quiz. You guys have the solution on Blackboard. So comments about the quiz. Now the first one, I have the solution on Blackboard and every student got some right, some wrong. So you guys please make sure you go over the solution. The true-false questions, there were problems with them. Not everyone, but there were some problems with them. So the first question in the true-false problem was the following. So you have a series sigma an, a1 plus a2 plus a3 plus etc. And the question was the following. If the limit of an equal to 0, then the series must converge. Okay, and it means that if those terms become small, the terms, not the partial sums, then the series must converge. And the answer is this is absolute, this is a false statement. Okay, and the example, the example that we've done a lot of is, let's take an to be, so a lot of students actually gave me the 1 over the square root of n. Then in this scenario, then the limit of the an is equal to 0, but the sum, when we start adding those terms, and this is something we did, I gave you the partial sums once in class. It means if I start adding those, adding them, now I'm doing something very different. I'm starting to add them. And then this sum actually will be equal to infinity. It means this series will diverge. And if I start adding those, the sum will diverge. And if you guys remember that once in class, I gave you actually the partial sums, and we realized that the partial sums were getting larger and larger and larger. And as I said once before, a lot of students told me it will converge because the terms are becoming very small. So that some students said, okay, if you keep adding, so if I add, and then plus 1 over 101 plus so on, those terms are small. So you're adding something very small, you get small. And basically, this is not true. And that's what's the difficulty of the subject. If you add infinitely small numbers, you don't get necessarily a finite number. So if you add infinitely small numbers, the sum can be equal to infinite, because they are intuitively, they are not small enough. Each term will contribute a little bit to the sum, making it diverge. And that's the reason we're doing all those testing, because our intuition does not help us in those cases. We need tests to be able to determine whether the series converge or diverge. So false for the first one. The second one, I have the following. So part B is the following. Suppose an less than bn, and sigma bn diverges, means the largest diverges, Does this mean, can I say immediately the smallest diversion? And a lot of you referred me to the theorem we said in class. And in class, we didn't say that. A lot of some of students told me it's true by the ordinary comparison. No, the ordinary comparison tells you if the smallest diverge, if adding those terms, you go to infinity, adding those will definitely go to infinity because each one of them is less than those. But if adding the larger blows up, there is no reason why the smallest, adding the small numbers is going to blow up. So again, this was a false statement. And a very simple example, if you can take the an to be 1 over n squared, very simple example. And the n, just take them to be 1, no more than that. Then, of course, an is definitely less than bn. Adding the bn, it means you're adding 1 to 1 to 1. This is gonna diverge. However, when I add the an, which is sigma 1 over n squared, this is converged because it's a p series with p equal to 2. Okay, so those were the two questions that gave some of you difficulties, and that's how we handled it. All right. So this is about the quiz. Please go over it, go over the solution, go over the comments I gave you. It's absolutely crucial that you understand the comment I gave you. All right. So now I go back to power series and how to find the interval and the radius of convergence. Again, I ask for your questions before I pick two just from the top of my head. I would rather do what you guys had difficulties with. Okay, the chat is open. I'll give you a minute to write your problems. Okay, I amended to everything, number 15. We will do that. Any other questions before that? Okay, so let us do number 15. We have the following power series. So a power series is a series where there is a variable x. And the goal is to find which values of x will make the series converge and which one will make them diverge. So I'm going to do number 15. And here I am in section 11.8. So number 15, we have this series. And this is a series in x minus 2. So that's x minus 2 to the power n over n squared plus 1. And my n goes from 0 to infinity. Okay. And the question is, which value of x I can put here and guarantee that the series will converge for this value of x. Last time I asked you the following question, can you give me one value? And everybody gave me 2, which makes sense because 2 minus 2 is 0. We end up adding 0 to 0. Yes, yes, Sarah, you're absolutely correct. Yes, 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 I will. Okay, so what's an here? An is x minus 2 over n squared plus 1. So we're going to use the ratio test to determine that. An plus 1 equal x minus 2 to the n plus 1 over n plus 1 squared plus 1. Now, to find out which x's are allowed, we're going to use the ratio test. Okay, for that, you have to compute the ratio between the an plus 1 and an. So let us compute the ratio. So that's the limit as n tends to infinity of the absolute value of an plus 1 over the absolute value of an. So this is going to be equal to the limit as n tends to infinity of. Okay, what's an plus 1? So an plus 1 is the following. X minus 2 to the n plus 1 over n plus 1 squared plus 1. Now, what is an? It's the absolute value of x minus 2 to the n over n squared plus 1. Now we're going to rearrange the term and do the math so that we can actually simplify this expression. So that's the limit as n goes to infinity of the following. All right. The top part will become the absolute value of x minus 2 to the power n plus 1 over quantity x plus 1 squared plus 1 multiplied by n squared plus 1, that's a positive number, I don't have to worry, over the absolute value of x minus 2 to the power n. Okay, let's see a little bit. This is equal to. So that's the following. That's the limit. As n tends to infinity of, I'm going to rearrange the term so that I can simplify. So the like term is n squared over n plus 1 squared plus 1 times the following. X minus 2 to the n plus 1 over x minus 2 to the n. All right? So now this is a quantity, this is a ratio that we need actually to compute. So I'm going to keep it in front of us a little bit and start computing it. So the ratio is going to be equal to what? The limit, I simplify as much as I can. All right, times x minus 2 to the n plus 1 over x minus 2. This would leave me to the absolute value of x minus 2. What about this piece? So this is basically n squared plus 1. The denominator, if I can distribute, it's going to give me n squared plus 2n plus 1 plus 1 plus 2. So now this is going to be equal to what? Divide by n squared here, divide by n squared here, and we realize that this term will go to 1. So this is going to be equal to the absolute value of x minus 2. So that's my ratio. So it depends on x. That's why we're going to do the discussion depending on x. So when is the series converge? So by the ratio test. Series converge when the absolute value, when rho is less than 1, when the ratio is strictly less than 1. What is my ratio? The absolute value of this is less than 1. What does this mean? It means where is x? It means this quantity here, if the absolute value, it means what's between those absolute value, which is the x minus 2, has to be between minus 1 and 1. So this quantity here has to be between minus 1 and 1. And now I solve for x. It means my x should be between 1 plus 2 and minus 1 plus 2. It means my x should be between 3 and 1. That's where my x is. So on the number line, what is my x? This is my 0, this is 1, and this is 3. My x should be somewhere here. Now the center of this interval is actually the 2. And so my series is going to converge between 1 and 3. Now, when it's going to be diverge? So that's when it converges. It means if I take any number between 1 and 3, if I take 2, 2.5, 2.9, 2.99, any number, and I plug it into the expression of the series right there, any number, I'm getting a series of numbers now. This one will converge. Now, to diverge outside that, it means it will diverge here, it will diverge here. So it diverges when x is less than 1 and x larger than 3. So now the only point I have to be concerned with are the endpoints. These are the only point I can be concerned with. So, endpoint. Notice, if x is 1, the ratio is 1 minus 2 is equal to 1. So if x is 1, the ratio test is give me 1. So when I'm going to check what's happening for 1, the only test that I will not use is the ratio, because the ratio will give me 1. So we have to use any other test. And if you see yourself using the ratio test, it means we're doing something wrong. So let us do the endpoint. What happened if x equal to 1? I'm going to plug this back into the expression of the series. So my original series is sigma x minus 2 to the n over n squared plus 1. And I'm going to put 1 in here. 1 in here, I will have 1 minus 2. It means minus 1 to the n over n squared plus 1. Now, does this series converge or diverge? I want an answer from you. Please get going on the chat. Does this one converge or diverge? Whatever your answer is, you have to justify it. It converged. Why it converged? You need always justification. I want somebody else. Tim, converge. You're absolutely correct. Converge. Why it converged? That's by the alternating series test. Because the Bn, the terms 1 over n squared go to 0, and they are decreasing. And decreasing. Okay, so at x equal to 1, my series converge. It means if I plug in 1 into the expression here, 1 in here, this is becoming a series of numbers, so there is no more x's in here, and this new series of number will actually converge. So now I'm still left with my absolutely last term, so I'm going to see what happened at the other one. So for x equal to 3, what is really going on? So that's my other endpoint, x equal to 3. So this is x equal to 3. I'm going to plug it back into the expression of the series. So that's my original series I'm working with. And now I said if I put x equal to 3 in this one, which is now, so I put x3, 3 minus 2 is 1, I'm going to have 1 over n squared plus 1. Now this is a series of numbers. And we already studied series of numbers. Will this converge or diverge? Again, I want answer and I want a justification for that. Answers with justification. So does this converge or diverge? What do you think? And based on what? Converge. Anybody else? Converge, absolutely. Always justification. So this is converge. Basically, you can use the limit comparison test with the series sigma 1 over n squared. So it's really behave like a p-series. Okay, with limit comparison test with 1 over n squared, which converges being converged because it's a p-series, p equal to 2. Okay, so now the question is, so what's the interval of convergence? So the interval of convergence, it means where does the series converge? Is the closed interval at 1 and closed at 3. And picture is, this is 1 and this is 3, and that's the center of your interval. So the series converge everywhere here, and the radius of convergence, basically the radius of convergence. So what's the radius of convergence here? Anybody understand what I mean by the radius of convergence? Right. The radius of convergence is not the length of this interval from here to here, it's 2. The radius of convergence is half the length. It's the distance from the center to the end, from the center to the end. So this is what we mean by the radius of convergence. So the radius of convergence is equal to 1. So that's how we fully treat this problem. Okay, any other questions before we move on? All right, so today we're gonna move to 1, 2, 3. Okay, we're gonna move, so those I will scan this problem and I will put it on Blackboard so you guys can review them. All right. Okay, today we're gonna move to section 11.8. And of course, you guys have all your notes on Blackboard, and so you don't have to write at all, but I will explain, of course, by writing myself. So today we're going to see something called representation of function by a power series. So we're going to write functions as a power series. So the goal of this section is to represent certain functions by power series. And before we start doing, all the math, what is really the idea? The idea is I want to write functions. Most of the functions we've seen, eventually by the end of next week, almost all the functions you've seen as a power series. First, what is a power series? Power series in X. What is a power series in X? You can think of it as a polynomial with infinite degree. So first, polynomials are expressions of the form like x plus 2x squared plus x cubed. This is polynomial of degree 3. And those are the easiest type of function we can work with. We can differentiate them very easily. We can integrate them very easily. And we can evaluate them very easily. That is very easy to work with polynomials. Power series, you can think of them as kind of polynomials, but with infinite degrees. And they will actually inherit everything we did on polynomials. You will see that we can do them on series of this form. We will be able to differentiate them very easily. We will be able to integrate them very easily. And more importantly, if I have a function, no matter how complicated it is, let us take e to the x. And if I show you that, if I convince you that this function could be written as a power series, it means I can write it as a polynomial of infinite degrees. The idea is I can use those polynomials to approximate the function e to the x. And actually, the way your calculators evaluate the exponential is by approximating it by the sum of its power series. Of course, I don't use a lot of terms. We're going to realize that very few terms will give us a good approximation of e to the x. So our goal now is basically to take functions, which are not very easy functions, and write them as a polynomial of infinite degree and approximate those functions by a polynomial. So today we're going to start in this direction. And we're going to take very specific function that you're going to write them as power series with a lot of algebraic manipulation. And later on, next chapter, we're going to see what's the general theory of that. But today we're going to do something that looks at the beginning hard, but eventually, actually, it's not very hard. So representation of a function by power series. So we're going to start with, at this stage, you guys don't have to write, all your notes are there. I'm going to start with writing the function, the most easy function, 1 over 1 minus x as a series. It means I want to write it as a power series in x. All right. How we're going to do that? We're going to go back to the beginning. I'm going to take a look at this series. 1 plus x squared plus x cubed, etc. Sigma x to the n equals 0 to infinity. All right? The first series we've ever seen. What type of series is that? I want answers now. What type of series is that? That's a geometric series. Very good. What's the ratio in this series. It's geometric. What is the ratio? The ratio is x. Agree with him? The ratio is x. From here to here, I'm multiplying by x, I'm multiplying by x. So, what does this mean? It means that if the ratio is x, for which values of x this series will converge? And what is the sum of this series? So, for which value of x it converges? Geometric, something we understand. Means that we know that if x, the absolute value of x is less than 1, if that's crucial, then this series will converge. So, and it converges to what? Do we know the value of this series? Do we know it converges to what? Remember the sum of a geometric series. As long as I take absolute x less than 1, the sum is going to be the first term, which is 1, times 1 over 1 minus the ratio. That's everything we've seen. So what does this mean to you? So it means that the following. It means so 1 plus x squared plus etc. This is 1 over 1 minus x when absolute x is less than 1. What does it mean? It means if I plug in x equal a half in this expression, it means 1 plus a half squared plus a half cube, and I start adding and adding and adding. Those sums are going to get close to a number, and they are going to get close to 1 over 1 minus a half, which is equal to 2. So that's really what it is. If you plug in a half in here and a half in here, those sums are going to be equal to 2. If I take x equal to 2, I plug it here, 1 plus 2 squared, this is diverge. So this equality doesn't really make sense. So this equality holds as long as the absolute x is less than 1. So that's so far what we know. Now I'm going to look at this problem with a slightly different point of view in the following way. Now that this is settled, we have that. Now I'm going to think of this as a function. The function that is assigned to x, 1 over 1 minus x. And I'm going to flip the order of this equality because I'm going to change my point of view. So I'm going to flip the orders, and what am I talking about? I'm talking about the following. I'm just going to flip the order. I'm not going to do anything else. I'm going to tell you that the function f of x equal 1 over 1 minus x. Now I'm going to look at this as a function. You give it an input x, it spits out this output. Is equal. It's given by this power series. It means this function now, I represented this function as a power series. And this representation holds when the absolute x is less than 1. It means that if I plug in a value here in the expression of the function that satisfies the property the absolute x less than 1, it means x equal minus a half, minus a third, minus 2/3. If I plug it into the expression of the function, and if I plug it in here, the partial sums here will get close to 1 over 1 minus x. This is, we call this the power series representation of 1 over 1 minus x of this function. So this is, sorry, I repeat, we call this equation the power series representation of the function 1 over 1 minus x. That's what this is called in x. So those sums, in a way, those sums here are polynomials. Those sums are actually polynomials. And what I am saying is that if absolute x less than 1, those polynomials, 1 plus x plus x squared, 1 plus x squared plus x cubed are going to become very close to the function 1 over 1 minus x. So that's the one I'm going to use basically this whole lecture to start building up power series representation of other functions. Right, so my example number 2 is going to be the following. So today we're going to just do basically drill ourselves in how we find power series of certain function by relating them to this one. So my first example is going to be the following. Find the power series representation of the function. So the power series representation of the following function. So I have my function f of x equal 1 over 1 minus 2x. It means I want to do the following. Write this new function as a power series. It means approximated by polynomial. How are we gonna do those type of questions? The way we are gonna do them is the following. Every time I give you a function, we have to relate it somehow. We're gonna use this basic one to find the power series of this new function. So I will do the first one totally in details myself, and then we start building up the idea. So we're gonna start with this, 1 over 1 minus x. That's gonna be my starting point. And my students usually memorize it. I mean, this is something we actually memorize. 1 over 1 minus x, I can write it as this. That's the power series. And in sigma notation, because now I want to emphasize both, I want to emphasize also the sigma notation, and this whole as long as absolute x is less than. Now, I want to write 1 over 1 minus 2x. Let us realize that this x here is a variable. Okay? As long as variable have satisfied this property, plugging it here or plugging it in the sum, we get the same answer. So now I want 1 over 1 minus 2x. How can I write this as a power series? Here's what we're gonna do. We're gonna substitute 2x for x in this equation. So what do I mean by that? Everywhere there is x, I'm going to put 2x because the format is the same. So this is x, 2x. If this holds when x at x less than 1, so instead of x, I can use 2x. So I'm going to write it as such. X squared. Every time there is x, is 2x. Every time there is x, there is 2x. Plus, etc. So in sigma notation, instead of x, I'm going to have 2x to the power n. But here is the thing. For which value of x will this hold? The original one hold as long as this variable in absolute value less than 1. So for this equality to hold, what condition on x should we have? Can anybody give me an idea? By plugging in 2x for x, what conditions on x we should have? So let me ask you a question. Can x in this equation be equal to 1? Can x be equal to 1? Yes or no? I plug in 1 in here. No, because if x is 1, 1 plus 2 squared, it fails. Let me ask you the following question. Can x equal, I don't know, can x equal 1/2? It means if I plug in 1/2 in here, what's going to happen? 2 times 1/2 is 1. 2 times 1/2 is 1. It means 1 plus 1 plus 1. So which axis I should be able to plug in here to guarantee that this series converges? Absolutely. I need absolute value of 2x to be less than 1. So to be able to, if I plug in 2x for x, it means this new term that I plugged in, for this equality to hold, it means for this to be equal to this power series, in other words, for this power series to converge, I need the 2x to be less than 1. Now with this given, the rest is going to be actually simple. That's basically the basic steps. The rest is going to be pure algebra to simplify this way of writing. So I will do the algebra. So it's going to be equal to 1 plus 2x plus this quantity squared. Remember, 2x squared means 2x times 2x is 2 squared x squared. Now I know this is 4x squared, but I want a pattern. I will not get rid of a pattern. That's why I keep it to x squared, etc. This is equal to what? Usually when you have a power series, I always want it to written clearly in the form Cn xn, this format. So let's see if I can write it like this. 2x to the power n. How can I split this algebraically correct? 2x to the power n is 2 to the n, x to the n equals 0 to infinity. So it means my function 1 over 1 minus 2x can be written as this sum. We can write it as this infinite sum, but I can do that when 2x is less than 1. But if absolute 2x is less than 1, it means x is less than a half. It means that this holds when x is less than a half. And that's the power series of the function 1 over 1 minus 2x. Means this function is equal to this sum, to this infinite sum, as long as absolute x is less than a half. And the radius of convergence here is a half. So mentally, if I take x to equal 1/4 and I plug it into this series here, and I start adding and adding and adding, this is I get the same answer as if I had plugged in x equal 1/4 in. So this function is nothing more than a polynomial of infinite degree as long as my x is less than a half. If x is larger, so if I take x equal to 3, the function makes sense, but it's not equal to this series because the series will diverge. So we're gonna practice those ideas today. So I would like to do 2 problems at least to be able to practice those. So the question is the same. Find the power series representation. I'm going to do a function which is important for us, 1 over 1 plus x. How I'm going to write this? And first step is I need to relate it to the only one we know. So we have to relate it to this one. And the question is, how can I relate it? Sorry, how can I relate this to that algebraically? It means, how can I rewrite 1 over 1 plus x so that somehow I can use this one? So in this piece, I'm trying to relate this to that so I can work. So how can I rewrite it so I can use 1 over 1 minus x? Okay. I'm going to rewrite it like follows. 1 minus, right, minus x. My goal now is to let it somehow, if I want to relate it to this, I want to know how I'm going to relate it to that. And now let's see how we're going to proceed. So now 1 over 1 plus x is equal to, I'm going to substitute minus x for x in here. So everywhere there is an x in I'm going to substitute minus x for it. That's how I'm going to get the power series of this function. So it's going to be equal to 1 plus. Everywhere I have x, that's going to become minus x. Everywhere I have x, this is going to be minus x squared. Everywhere I have x, it's going to be that. So I'm going to substitute minus x. So, and I will always do it as in the sum terms, and I will do it in sigma notation. And I will ask you to do the same. So this is going to be sigma. That is 0. N equals 0 to infinity. Instead of x minus x to the 10. And instead of absolute x less than 1, it's absolute minus x less than 1. Means this equality holds as long as the term I substituted satisfied this condition. The term I substituted was minus x. And now we're going to do the algebra to write this properly in a sigma notation. So it means that my function 1 over 1 plus x is equal to 1 minus x plus x squared minus x cubed plus etc. So in sigma notation, this is going to be equal to n equals 0 to infinity. Now minus x to the n, how can I rewrite it as like cn x to the n? I mean, how can I take this minus out of this parenthesis? Okay. How do you think? I'm going to rewrite it as minus 1 to the n xn. Okay, that's how we can do that. And now, for which x's this hold? It means I can never write this equality unless I tell you which x's are allowed in this equality. But the original one is true when the absolute minus x is less than 1. But now I'm going to ask you the following question. Is the following true? Is absolute minus x equal to the absolute x? Yes or no? Absolutely yes. So if absolute minus x less than 1, it means for absolute x less than 1. So the radius of convergence here is equal to 1, and the interval of convergence is minus 1. Another one of the important power series representation is 1 over 1 plus x. So again, this tells me if I take any x, so suppose I take x equal whatever, a number here, 1/2. So this is telling me that if I plug in 1/2 in here, and I plug it in here, any x, I compute this number, and I start adding those terms and adding them and adding them, I get exactly the number I got right here, as long as my x is less than 1. So this is called the way representing the function 1 over 1 plus x as a power series. All right, more examples along the same lines. And I'm going to give you a few minutes to tell me what to do. Our main idea is any series, any function I'm giving you, I want you to relate it to the one we know, this one. Or sometimes you can relate it to that one. So I'm going to give you now a series. I'm going to let you think about it for a minute. And I want you to relate it to something we know. So I'm going to take the function f of x equal 1 over, I don't know, 2 plus x. And the question is, find the power series of this function. Meaning, I wanted to write this as polynomial of infinite degree, basically. That's really what a power series. And the way you're going to do that is by relating it to something we know. So actually, to make it even easier, I'm going to put 2 minus x. Just to make it a bit easier. All right. I want you somehow to relate it to this. How can I relate them? So I want this somehow to look very much close to that. How I'm going to rewrite it. So this requires 1 minus a variable. This is 2 minus the variable. So to be able to find the representation of this function, I have to rewrite it. So it looks like, rewrite, and I'm very clear about that. So it looks like 1 over 1 minus something. That's how I'm gonna relate it to the original function. I give you 2 minutes just for yourself to think through that. I'm not with you to be able to. So I want you to relate this, relate to 1 over 1 minus the variable. So how can you rewrite that? So I'm relating the function to each other. Replace x with x minus 1. So, okay, I'm trying to understand. So the idea is that this will not change. So you want to write it as 1 minus x minus 1. Is Jordan correct algebraically? Is he correct algebraically? Yes, he's absolutely correct algebraically. No, why? If I compute, I will get 1 minus x plus 1, which is 2 minus x. So algebraically, he is correct. Now, and that's interesting. Okay, I follow Jordan's approach, and I will tell you why it will work sometimes and why it will fail sometimes. All right. So if I follow Jordan, and this is going to be written as, so 1 over 1 minus x is 1 plus x cubed, x squared plus x cubed plus so on. So according to Jordan, what should I substitute for x? So 1 over 2 minus x equal. What shall I substitute for x? According to Jordan, I should substitute x minus 1 for x. So this is going to give me 1 plus x. What he said was correct, but I'm going to tell you what happened if I follow him verbatim. Plus x minus 1 squared plus x minus 1 plus so on. So this tells me, this give me 1 over 2 minus x as a power series in x minus 1. Because you're going to get x minus 1 squared plus x minus 1 cubed. So if my question, find a power series in x minus 1, Jordan will be 100% correct. Now, if I ask you to find a power series in x, power series in x, it means I want the term to be c0 plus c1x plus c2x squared plus c3x cubed plus so on. In this scenario, Jordan's way of doing it will not allow me to write it this way because I don't know what coefficient of x is. I don't know what's the coefficient of x squared. Things will become more complicated. So your classmate Jordan is correct. If I ask you find a power series in x minus 1. If I ask you find a power series in x, then I cannot use this approach. So I'm going to then rephrase my question and I'm going to write as a power series in x. So with this in mind, I cannot use Jordan's approach, even though it's perfectly correct, but it will give me x minus 1s here, but I don't want the x minus 1. we're going to need them later. I want the x's. So how can we tweak it again? Even though it's a very good idea. Factor out the half. The 2 is bothering me. I want to factor it out. So I can go back to this. So it's going to give me 1 over, I'm going to factor out the 2. and this become 1 minus x over 2. So which we're gonna become a half times 1 over 1 minus x over 2. So it's almost like, so don't worry about the half, I will tell you what to do with it. So now I almost rewrote it as 1 over 1 minus something. Now I can actually start using the 1 over 1 minus x. At this stage, I'll go through all the details. So now I keep 1 over 1 minus x always in front of me. X less than 1 and equals 0 to infinity. I put it in front because I always want to substitute in it. And now I go back to my function. That's the one I want to write it as an infinite polynomial. So this is equal to a half. So far I'm rewriting. I am not at all changing anything. I'm not changing my expression. I'm just rewriting it so I can use the previous one. So now this is going to be equal to a half times. Now, 1 over 1 minus x over 2. Now I'm going to substitute x over 2 for x. X over 2 for x. And if I do so, I'm going to get 1 plus x over 2 plus x over 2 square plus x over 2 cube plus etc. Now I always want the term written this way, and I want in front of it the sigma notation, so we get very comfortable with the sigma notation. So this is going to become sigma. A half, we will take care of it in a sec, as I said. Instead of x, I am putting x over 2 to the power n equals 0 to infinity. But the original one holds as long as the variable here is an absolute value less than 1. But now instead of x, I'm using x over 2. So this is going to become, I need the x over 2 to be less than 1. That's when this holds. Now let us do the algebra. At this stage, we did the calculus, and now I'm going to do the algebra because I want to write it in the form sigma cn x to the n. So I want to be very precise. So I'm going to do the first algebra here. This is 1 plus x over 2. This is x squared over 2 squared, and this is x cubed over that. Okay, I'm not doing much, I'm just doing algebra, which is crucial. And this will become from 0 to infinity. This will be x to the n over 2 to the n. And x, this will give me absolute x over 2 less than 1, which will take care of it in a second. Now my final step in the process. This is a sum. A half times that, you just distribute the 2. Sorry, we're distributing the half. So if I distribute the half, I'm going to get 1 half plus, I'm just distributing, x over 2 squared plus x squared over 2 cubed plus x cubed over 2 to the power 4 plus so on. I'm just distributing. So with this in mind, I'm going to distribute the half inside. So it means now this, I'm going to basically bring it inside the sum because I can do that. So it's going to become xn over 2 to the n. Basically, I'm going to multiply each term by a half. So this 2 to the n is going to become 2 to the n plus 1. So where is this 2 to the n plus 1 coming from? Where is this coming from? It's coming from the following. every term is xn to the n, but I'm multiplying each one of them by a half. It's going to give me xn over 2 to the n plus 1. And this is going to hold, so this is hold as long as the absolute value of x is less than 2. And this is going to give me the power series of the function 1 over 2 plus x. Okay, now one way you can, usually I like to do, is to make sure that my notation, those two basically coincide. I go backward. I said, okay, does this and this are the same expression? Okay, let's say if n is 0, this is going to give me x to the 0 over 2. It means 1/2. If n is 1, this is going to be x over 2 squared. So I am on the right track. Basically, those coincide. If n is 2, I'll have x squared over 2 to the power 3, and so on and so forth. And this is give me the representation of the function 1 over 2 minus x. And this equality hold as long as my absolute x is less than 2. Okay? On your notes, you have one more example. Please read it. It's explained well, and then do the homework. Okay, now one more thing I'm gonna actually make you do for tomorrow. I'm gonna give you, I'm looking at my grade book. Back when you were seeing each other, I gave you a quiz that's over 10 points. And I wanna make it out of 20 points. So what I'm gonna do is the following. I'm gonna give you your regular homework for tomorrow. And I'm gonna give you one power series as a quiz for tomorrow. As a take-home, not in class. So I'm going to give it to you as a take-home quiz for tomorrow. And I'm going to open Blackboard so you guys can hand it in on Blackboard. It's going to be due by 10 a.m. tomorrow morning. And the quiz will be, I'm going to give you a power series, one that I gave you in the review, and you have to find its radius of conversions. So I want you to do that for tomorrow. I'll open the quiz, as I said, in a few minutes. And this is going to be due tomorrow at 10 a.m. on Blackboard. So this has to be turned in on Blackboard. And I want you to do the homework. Very important to be able, you know, to do well on the test. All right. Did you guys look at the review? The review is already on Blackboard for your exam. Please start working on it. And I have office hours, as you guys know, right after class. So please join me if you have questions about the quiz, about anything. Okay, and I hope tomorrow you guys will ask me more questions. Okay, bye-bye, and join me in my office hours if you guys would like to. Bye-bye.